5, lesson 6, we are going to use the Pythagorean theorem. Okay, it says here, list 2 headings you'll use to make an outline of the lesson. So, when you were looking through, what did you think? Yes?
Pythagorean theorem.
We're looking at the Pythagorean theorem. What else? So, the Pythagorean theorem, and we're going to learn how to solve a right triangles. Okay? All right. So, when we look at the real world link, it says, in parasailing, a tightrope is used to attach a parasailer to a boat. What type of triangle is formed by the horizontal distance, the vertical height, and the length of the tow rope? Yeah. This is a right triangle. Very good. This is a right triangle. So here, when we have a right triangle, okay, well, we know this is a right triangle. And to explain here, whenever you drop a height, it always meets the bottom of the triangle at a right angle. That's a rule, okay? So when you drop a height here, if we were to drop a weight there, it would go straight down, and that would be a right triangle. All right, so the way that we know this is a right triangle, okay, just like we learned in the previous lesson, if I take the legs, the A and the B, and I square them, I should get the square of the C, right? So, if I did A squared plus B squared equals C squared, then I did 72 squared plus 21 squared. That should give me a true statement with 75 squared. Is everybody clear? So, because when we put it into the formula, we end up with a true statement, we know that that is a right triangle. Is everybody clear? All right, very good. So, it says, suppose the wind picks up and the parasail rises to 50 feet and remains 72 feet behind the boat. Write an equation that will help you find how much tow rope the parasailer will need. Okay? So what am I solving for here? A, B, or C? We're solving for C, which is the, starts with an H, hypotenuse. Very good, very good. So now we're going to change. It says, suppose the wind picks up and the parasail rises to 50 feet. Okay? He stays, or she, he or she, I don't know, stays at 72 feet behind the boat. We want to now solve for C, right? So we do that by using our Pythagorean theorem. So using our Pythagorean theorem, 72 stays the same. He's still 72 feet behind the boat. He went higher to 50 feet, and we want to know how much tow rope C he needed. So when we did that, we ended up with 87.7 feet for C. Got it? Very good. Suppose a tow rope is, oh no, wait, I skipped one. Solve the equation to find the amount of rope parasail will need to, oh, so we did that. So that's going to be 87.7 feet, right? Then it says, suppose the tow rope is 300 feet long and the parasailer is 200 feet above the water surface. Write an equation to find the horizontal distance behind the boat. Okay, so this time we're solving for B, right? So we've got A squared plus B squared equals C squared. It says now the tow rope, C, is 300 feet long, right? So this is going to be 300. The parasailer is 200 feet above the water. So we have the 200 here. And it says write an equation to find the horizontal distance. So plus A squared. Okay? we have to square, we have to square those too. Okay. So here, we're going to have a squared plus 200 squared is 40,000 is equal to 300 squared, which is 90,000. Okay? How do I get the a squared by itself? Subtract 40,000. So a squared is equal to 50,000. And how do I get the a by itself now? Now we're going to find the square root on both sides. Oops. So, a then is equal to 223.6 feet. Is everybody clear? All right. Very good. And yes, up here on problem 3, it says round to the nearest foot. So here, if we have 87.7, the nearest foot would be that, right? So the 7 tells us what to do, so our final answer then would be 88. Very good. 88 feet. You got it? All right. Very good. So, solving a right triangle. The Pythagorean theorem can be used to solve a variety of problems. It is helpful to use a diagram to determine what part of the triangle is unknown. So for the example 1, and you guys don't have to write this down in your text, because it's in your text and it's already all the way given, okay? We want to write an equation that can be used to find the length of the ladder, then solve, and we want to round to the nearest 10. So here, the ladder is leaning against this tower, this building, right? We know that this measure is 8.75 feet. We know that the height at the point where it's leaning is 18 feet, okay? So we want to know how long that ladder is. Is everybody clear? All right. So here we're using the Pythagorean theorem. So if a squared plus b squared equals c squared, we put in what we are solving for. We enter what we're solving for, so it's 8.75 squared plus the 18 squared, and then we're solving for the c. And then we continue with our calculations, and we end up with c is equal to a positive or negative 20 feet. But, is it a positive or negative? No, it's just a positive, because you cannot have a negative length of the ladder, right? Okay. Same thing when you are trying to find the distance. So here it says write an equation that can be used to find the height of the plane, then solve. So here we've got the first plane down here, the second plane up there. We want to solve how far above the second airplane is to the first airplane. Okay? And again, we're just using the Pythagorean theorem. So you've got a squared plus b squared equals c squared. When you put those numbers in, you end up with 10 squared plus b squared equals 12 squared. And we're just solving for b. You got that? We end up with 100 plus b squared is equal to 144. And then how do I get that b squared by itself? You're going to subtract 100 on both sides. Very good. So you end up with b squared is equal to 44. And then your final answer is going to be a 6.6. Okay? And again, we don't use the negative because we don't have a negative distance. Okay? Mr. Parsons wants to build a new banister for the staircase shown. if the rise of the stairs of a building is 6 feet, I'm sorry, 5 feet, so if the rise is 5 feet, and the run is 12 feet, rise over run, remember that? Rise and run. So if the rise is 5 feet and the run is 12 feet, we want to know what will the length of the new banister be? Find C. So all you're going to do is use your Pythagorean theorem. So we have a squared plus b squared is equal to c squared. What am I going to substitute in here? Okay, 5 feet. So 5 squared plus 12 squared is equal to c squared, right? So now, all we have to do is simplify. All right, so we've got 5 squared is 25, plus 12 squared is 144, and then we're going to, that's going to be equal to c squared. So this is going to be 169 is equal to c squared. Now, how do I get c by itself? Very good, very good. So, c then is equal to? 13. 13 what? 13 feet. Very good. So the new banister, baluster? The new banister is going to be 13 feet. All right, the Pythagorean theorem in 3 dimensions. Okay, you can use the Pythagorean theorem to find missing measures in 3-dimensional figures. Now, you use it the same way, okay? You use it the same way. All right, a 12-foot flagpole is placed in the center of a square area. To stabilize the pole, a wire will stretch from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner of the square. What is the length of each wire round to the nearest tenth? Let's see. The flagpole is 7 feet from each corner of the square. What is the length of each wire round to the nearest tenth? Okay, now this one again, you don't have to write this down because you already have it in your textbook. Okay? So, when we look at this picture, our A is going to be right here. That is going to be our A, right? Our B is going to be what? The 12 or the pink dotted line? No. The 12. This is going to be our B. Because remember, the hypotenuse, C, is always opposite the right angle, right? So, here's the right angle. So, C is right here. Everybody clear? All right. So, now we have a squared plus b squared equals c squared. A squared plus b squared equals c squared. And then we substitute in. So we have 7 squared plus 12 squared is equal to the c squared. And then we calculate down to 13.9 feet. So everybody got it? All right. So let's do one together. The top part of a circus tent is in the shape of a cone. The tent has a radius of 50 feet. What's radius, by the way? Is it all the way across? No. It's just halfway across a circle, right? Through the center of the circle. All right. Okay, I got distracted. The tent has a radius of 50 feet. The distance from the top of the tent to the edge is 61 feet. How tall is the top part of the tent? And we want to round to the nearest whole number. Okay? So, what am I going to start with? What should I always write when I start? I should always write my formula. So, we have our Pythagorean theorem. A squared plus b squared is equal to c squared. Okay? Am I solving for A, B, or C? Either A or B. Very good. Very good. So let's just say A. Okay, let's solve for A. So we've got A squared plus 60 squared is equal to 61 squared. Okay? And now we just simplify. So A squared plus 2,500 is equal to, thank you, 3,721. Now, to get the A squared by itself, we will subtract 2,500 on both sides. And what do we get? A squared is equal to?
1,000.
Very good. And now, finally, how do I get the A by itself? Find the square root. Good. So A then is equal to 34.9, right? But then it tells us to round to the nearest whole number. So my final answer for A would be what? 35 what? Perfect. Are there any questions? Let's see.